Now let us see the limits involving infinity. That means there are certain questions in which the variable x tends to infinity. So in other words, that is growing without any bound. It's not approaching any finite number, but it is just increasing and increasing. Now if you take a simple function, that is say f of x equal to 1 upon x, we see that x is in the denominator. Now if this denominator x increases without any bound, that means if x approaches infinity, 1 upon x will obviously become smaller and smaller and smaller. So therefore that particular quantity will tend to 0. Okay. Now instead of 1 upon x, even if we take any other higher power of x, say 1 upon x square, and if we want to find the limit of this entire quantity as x approaches infinity, then this will also obviously tend to 0. So therefore summarizing, we have this particular general formula, that is the limit of 1 upon x raised to n as x tends to infinity will be equal to 0. Okay. So in the limits that involve infinity, what we have to adjust is this particular term. Okay, that is 1 upon some power of x, that will be definitely tending to 0. Okay, of course that n has to be a positive real number. So now let us solve few sums based on this. Okay, here is the first question. We have to evaluate the limit as x tends to infinity of x square plus 2x minus 5 whole upon 3x square minus x plus 1. Now here if you observe, both of the expressions are quadratic in numerator as well as denominator. So what do we do is we divide both numerator and denominator with the highest power term. Now here the highest term is the quadratic term, which is x square. Alright. So let us divide both numerator and denominator by x square. So on dividing numerator, we will get 1 plus 2x upon x square will give us 2 upon x, and 5 divided by x square is the last term, divided by, in the denominator we have first term as 3, then minus 1 upon x plus 1 upon x square. Now we'll see the benefit of doing this particular adjustment. Now see, as x tends to infinity, what happens is 2 upon x, 5 upon x square, 1 upon x and 1 upon x square, all these 4 quantities will reduce down and they will approach to 0. So therefore in the limiting condition we have 1 plus 0 minus 0 whole upon 3 minus 0 plus 0. So therefore finally we get 1 by 3, which is a very finite number. So initially we may think that by putting x equal to infinity directly, we may get something like infinity by infinity, which is a meaningless expression, that is called as indeterminate form, as we will see later. So therefore the trick is to divide by the highest power, that is x square. Now let's see one more interesting question. Here we have to evaluate the limit as x tends to infinity of root of x square plus 3x whole minus x. Now here we don't see any denominator as of now, that is there is no denominator given other than 1. So what do we do is we somehow bring that denominator, and the way to do that is, if you observe, this is an irrational term, that is we are given a square root. So as we have seen previously in the rationalization method, the same thing we will replicate here also, that is we will multiply and divide by the conjugate of this particular numerator. So that will be root of x square plus 3x plus x divided by the same expression. Alright. So in the numerator we have a minus b into a plus b, so that gives us a square, which is x square plus 3x, minus b square, which is nothing but x square. Alright, so the second quantity is square is subtracted, whole divided by denominator is root of x square plus 3x plus x. So if we see in the numerator, x square will get cancelled and we are left with 3x. So what we can do is we can bring that 3 outside the limit. So that will be 3 limit x divided by root of x square plus 3x plus x as x tends to infinity. Now if you observe, the numerator is a linear term. In the denominator also we have one linear term, which is x. And if you observe the second term, it is quadratic in x, but it is inside the square root. So eventually we can think of this particular term to be of linear nature only. Okay. So therefore what we need to adjust now is, let us divide numerator and denominator by x. So therefore what we'll get here is numerator will become 1. Here the first term, which is x square plus 3x, will get divided by x, and the second term is already x, so that will become 1. Right? So simplifying that further, here we have 3 into limit as x tends to infinity 1 upon, now whatever x we have, let us take that inside the square root, so that making it a bigger square root, what will be left out with is x square plus 3x whole upon, x will now become x square because it has come inside the square root, lastly plus 1. So that is equal to 3 into limit as x tends to infinity 1 upon, inside the square root we will have 1 plus 3 upon x, right? Whole plus 1. Now if you see, we have got the required form, that is x tends to infinity, and we have got the term in which x is in the denominator. So therefore this particular term will eventually approach to 0. So therefore limit is nothing but 3 into 1 upon, it will be square root of 1 plus 0, which is 1, and root of 1 is 1 plus 1, which is 2. So therefore the final answer is nothing but 3/2. So this is how we evaluate the limits involving infinity.